as a potent of alpha glucoside inhibitor. So this this is the thiodeuterion compound in which this hydroxyl group and this sugar moiety type. So till 6 we can manage because we have furanols and pyranols. So till number of 6 carbon we can easily form like poncoronol and neoponcoronol. We can easily synthesize. What the problem coming here? Catanol and neocatanol. So in that case, 7 carbon is there. So how we increase one more in stereo center there? This is the big problem in this synthesis of catanol and neocatanol. So this is the previous report of total synthesis of catanol. First, they started with persitol. They protected and followed by nucleophilic attack of this thio compound, and they made this particanol. This is the structure of this catanol. So, and second, they use two type of reaction, different starting material. So they started from, they did Wittig reaction followed by asymmetric hydroxylation. So they synthesize this catanol and neocatanol. What the big problem of these this first this one and these all is, this first is construction of this chain sugar chain is very problematic, because first if they started for d-paracetal means this is very costly. So this is the first problematic in this first synthesis of this neocatanol. And in second case, they are increasing the number of carbon using this Wittig and asymmetric hydroxylation. So in that case, this Wittig is fine, but in this case, E and Z is forming and followed by this hydroxylation. So the yield is coming very less. So in mind of this point, this recently this group start the synthesis of neocatanol using this septanoside. So this is the retrosynthesis, this septanoside and using of oxyglucose. So forward synthesis, what they did, using this hemiacetal followed by chlorination and using SOCl2, and they synthesize this oxyglucose followed by the cyclopropionation and ring opening using sodium methoxide, and then oxidation followed by reduction. This reduction in using NaBH4 is very much diastereoselective, so only one this 32 septanoside is forming. Using this, they did protection using tretyle selectively 6 position, followed by acetylation of this one, and functionalize this 6 position and nucleophilic attack of this thio compound, and deprotection and followed by ring opening in NaBH4 condition. So this is the straightforward synthesis they use to synthesize this neocatanol. Here this is Wittig free and Wittig and SM metal free reaction. So they approaching this synthesis of neocatanol is the Wittig free and very efficient for the synthesis of neocatanol. Then they start to synthesize this change of this protecting group on these two positions, because the more hydrophobic is useful in enzymatic process. So they did this selectively protection of this 4 and this using change of equivalent, they synthesize this 41A. And this then the same, they use same procedure after this functionalization of 2 and 3. They again attack of this followed by deprotection and remove. So this overall in this method, they don't use any Wittig reaction and asymmetric. This only using the synthesis of septanoside followed by ring opening. Thank you.
So that compound is a natural product.
Natural
Go to the
product. This one. First
your title slide.
this one. This is the potent sulfoniums are isolated from space.
What is the use of this? Any application?
They used like glycoside type like the enzyme like they are using, and they did IC50 also they calculated for this.
Make it full screen. Full screen.
So these are inhibitors, like as you have
Huh.
written glucose. So in this current synthesis also they are making another glucosidase inhibitor.
Okay. Alpha glucosidase inhibitors. Silicious species plants. And another thing is that 39 to 40, there is that reaction right for normal HCl. They are deacetylating everything.
This one.
Generally, we are using acetyl chloride if there is acidic deacetylation.
Huh.
Uh, so
Okay.
uh, for for acetylation, we are using pyridine acetic anhydride, and while workup, we are using the 10% of the HCl. So why in that case this acetyl group is not going? Maybe it is not that much strong.
Which one you are
Uh,
saying? This
Generally, we are using one normal, for example, one normal of the 1 molar normal, same for HCl.
addition, this
hello.
sulfonium salt maybe get substituted or something. Like this is salt, right? Sulfonium salt compound
Mm-hmm.
39. If you use
Mm.
Gemplin condition, I feel it will maybe OME will come there. So that's why they are using HCl. And since they have two four-state group, that's why this is not selective deprotection. That's why probably they are using directly HCl, not acetyl chloride.
And
Okay.
second thing, this in presence of sodium methoxide, this may be act as leaving group and attack here and leave.
And
Yes.
salt itself will leave. OME will attack over there.
Huh. Yeah.
Yes.
But I was
But
thinking
I
about
think
that.
this is
Uh,
mm,
we are using one normal
And
HCl to wash the pyridine, right?
boss, yeah,
So that
pyridine,
is,
but this is one
uh,
normal and this is four
that
normal. So
that
maybe
is
the
yes,
concentration
yes,
effect.
yes.
This is
That is
very
the
much
only one.
diluted be used in Barcup.
Hmm. And maybe it require more
Or
time.
we can do one
We are
thing.
just washing once
This
and we
we
are just
don't
removing
this
the water.
maybe sometime yield is decreased
Hmm.
in case of if we are using but we not observe these things.
Yeah, maybe some compound is going what into the
Maybe
water or
yeah.
something.
so in this case, this septenoside ring is getting opened and it is becoming this open chain paracetal.
This case of 8 neocatenol.
Yes.
Yes, they using NaBH for their opening. In normal this acid form, it is not opening; it is closed.
Okay. Good.
Okay, H2PDC, 80% of acetic acid, then NaBH for they are using.
This OVN, this deprotection
Opinion.
followed by ring opening using reductive ring opening of this septum.
4%. And what they are showing here, 32 to D per cetol. That is normal.
Yeah, this is commercially available. This is normal ring opening, like if not their same procedure, they used deprotection followed by NaBH4, this will form.
Okay.
So this one, the problem then again they need to protection, but using this selective protection is problematic here, because for this we did first selective protection, then this. So here no selectivity because this and this one is same.
Okay.
If from D-paracetal they start, you are thinking not do this and direct start from here, this previous synthesis. So the problem is selective protection of these two, because this is the
Mm.
mirror image of this one.
But the stereochemistry of the all the hydroxy groups are same in the paracetal and neocotanol, right?
Hmm.
It's just a problem of
Just
stereo
yeah, everything is same. Only this.
regioselectivity is not there
Uh,
in protection. Okay.
and this is very much costly. Where this cost is $800 per gram.
Okay.
It,
And this 32 is not costly. This can be
32.
synthesized easily.
We can easily synthesize this here to the.
but the another question is that you're also doing this oxychloroquine formation reaction. So why people
Uh,
are using DCE as a solvent? Why not the other
E
dichloroethane as a solvent? Why not the others?
dichloro DC.
Uh,
Here.
In first step, that reaction you are performing, right? 27 to 28.
No, no, I am not using this method here. The problem is if you how you may make this hemiacetal. This is the problematic.
no,
No,
no. But
but
in other
it's
reaction you are using DC, right? Some reaction you are
DC
doing.
I am using DC.
Why not the DCM, for example?
DC and DCM you are saying. So
Uh,
maybe the this hydrophobicity because CH2 is increasing in between.
like, did you perform those reactions in DCM anytime instead of
No, no,
DC?
no.
Since that is established, you are using DC directly.
Uh,
maybe some yield problem or something. Yield is decreasing or something is there.
in that case, via this hemiacetal synthesis is not easy. Maybe they have that's why, or they ordered commercially, then they use.
Why this can be made, right? 27
Yield is
you cannot make from this thioglycosides.
Then four,
uh,
five step we needed now. First acetylysis,
Okay.
then thioglycosylation, as this OAC protection, thioglycosylation, then
mm,
followed by hemiacetal synthesis. Then we use this method. And my case, directly you take this methyl, do benzylation and acetylysis.
okay,
Okay.
but we can use this method, but it is longer
This method I
process.
used first when I was not able to acetylysis. I did this OME is there. I did this hydrolysis reaction using for this HCl and reflux condition. I did synthesize this one,
Okay.
but in
So,
that case, charring problem is there, so yield was very less.
so in this reaction, in situ chloride is forming,
In
anomeric
situ
chloride.
chloride is forming SOCl2.
So that again base will go. Okay.
And yesterday I am thinking I have this hemiacetal in septanoside and OAC is there. So that I am thinking if OAC is not problematic, I will also do same reaction.
Okay. We'll go to next slide. So this is here they are showing selective protection or what?
They are showing the increasing the number of carbon, hydrophobicity is increasing. So it will useful in enzymatic reaction.
Okay.
So they are changing the protection group here.
Okay, okay. But in both case, reagents are same. In one case, so they have purified or what? In one case, they are getting this to C3, in another case, C4 protection.
No, both and single. They, if equivalent is very much this
Okay, okay.
1.2
One is
equivalent they are
butyl.
using. So more near about 80% they are getting this one.
Yeah, yeah, both are different. I thought both are benzyl bromide. One is BN, one is butyl. Okay.
Butyl.
Okay, good.
Can I stop?
Yes, if no further questions are there, you can stop.
No, you go to the previous slide. Actually, my
Which
team
one?
was having some problem. By the time I joined, I almost completed the presentation.
Okay, I'll showing from
Yeah,
starting
can
one
you
by one.
go to the next slide? No, that wherever the photosynthesis kind of a thing. How did the exact 39 reaction happen? Is it just a nucleophilic substitution of the triplet group?
39 to which one?
37 to 39.
37 to 37.
Hmm.
This act as a living group. Here is R is equal to TF na
That's
OTF.
what I'm saying. It is just a nucleophilic substitution
A
reaction.
nucleophilic substitution just.
Then what is this IRA402?
This is the ion exchange bias, chloride.
Oh, ion
Here
That
exchange
is
chloride
resins.
is
resins.
coming.
Yes.
Resins type.
Oh, okay, okay, okay. Oh, so okay, from that resin, Cl minus will come.
Because they want to
Uh,
replace this OTF as a.
mm. So since you are discussing about this neoketal glycosidic inhibitor, right? So
Uh,
it is in most of the case they sometimes used as a bacterial inhibitor. Like they will inhibit the glycosylation of bacterial cell wall or some glycosylation that is what is responsible for the survival of the bacteria. So these things, this molecule, since they are inhibiting the glycosylation, so they can kill the bacteria or for any other organism. So that is the use of these glucosidase inhibitor molecules.
yes.
Mm. Okay, thank you.
Okay. Thank you. Yeah. Okay.